Welcome to the deep dive. Today we've cracked open a pretty significant pile of source files on a topic that is just foundational to modern software development.
It really is. We're talking about the architecture of GitLab.
And this is the structure that defines collaboration. It doesn't matter if you're a small startup or, a massive multinational company.
Exactly. Understanding how all the pieces fit together, how projects are contained, and more importantly, how access is granted, it's crucial.
Right. And we're not here to just read a manual. Our mission today is to cut through all that complexity and deliver the essential knowledge you need to be, well, functionally expert in this.
We're really focused on three things: the hierarchy, what you could call the fences, and then this immutable rule of inheritance.
And that last one, inheritance, that's the one that prevents security meltdowns. It's also where most people get tripped up. Okay, let's unpack this.
So we have to start right at the top. Foundational building block. The concept of the namespace. It's the organizational container, the unique identifier, the high-level address for everything that follows.
So nothing can exist without it.
Nothing. Every single project, every group, it has to live inside a namespace.
Okay, so it's the legal domicile for the entire structure. If the namespace is the container, then we need to know who owns that container.
Right, because there are two distinct types, and their intent is totally different. The first is the user namespace.
My personal space.
Pretty much. This container is tied directly to an individual user account. Its main purpose is exactly what you'd think. It's for your personal projects, sandboxes, small experiments.
The half-finished documentation I don't want anyone to see yet.
Exactly. It's owned by you, and its existence is fundamentally tied to your account. Simple.
Okay, what's the second type?
The second type is the far more strategically important one.
Yeah.
The group namespace. This is the container designed specifically for collaboration, for collective ownership.
So when we're talking about a company, an enterprise structure, we're almost always talking about building on top of a group namespace.
Always. It can have multiple owners, multiple administrators. It's the genesis of the entire organizational architecture. That container becomes the company's master root, the top of the pyramid.
And once we establish that, we start defining the structure inside it.
That's the key shift. Inside that group namespace, we build out the structure using groups. Groups are the primary organizational units. They're the true backbone of the system.
And the actual work, the code, the repos, the issues, that lives in a project.
Correct. So projects live inside groups, and those groups live inside that main namespace. That's the core relationship.
A project can never just float freely on its own.
Never. It has to be an artifact of an organizational unit, which is the group.
Okay, so for a small team, a flat structure sounds fine. One group for Acme Engineering and 10 projects inside it. But what happens when you scale?
That's where things get complicated. You don't just have one engineering team.
Right. You have regional teams, compliance teams, infrastructure teams, maybe multiple product lines. How does GitLab handle that kind of organizational complexity?
This is where subgroups become critical. The system allows a group to contain other groups.
So you can nest them?
You can create these deep, potentially infinite, nested organizational structures, and this is absolutely essential for any enterprise.
Can you give us a practical example? Like, why is that deep nesting non-negotiable? Why can't we just stick everything under one giant group?
Well, think about compliance and operational boundaries. Let's say you have a global parent group for your company.
Oh.
Beneath that, you might have a subgroup for Europe operations and another for Asia-Pacific operations.
Different regulatory zones, different governance rules.
Precisely. Now, within that Europe operations subgroup, you could create even more subgroups for, say, CI/CD runners, security scans, or specific customer projects.
Ah, I see. So that granularity lets you isolate settings.
You got it. You can restrict which teams can use specific build infrastructure or apply unique authentication rules only to the teams working on, highly regulated code. It's not just about neat filing.
It's about granular operational control.
Yes. What's fascinating here is that once you've built this map of your organization, you then have to dictate who's allowed to even see the map.
Right, which brings us perfectly to the concept of visibility. This is where we put up the fences for your data.
You've built this beautiful, complex structure. Now you define the scope of access.
And here's where it gets really interesting. How do the three primary visibility levels control who can view the content?
The settings are simple in definition, but they're incredibly powerful in application. You can apply them at the group level or the project level.
Okay, so lay them out for us. Start with the broadest one.
We start with public. If a group or a project is set to public, it is fully accessible and viewable by anyone on the internet.
Anyone. Logged in or not.
Logged in, not logged in, just passing by. It's great for open source projects or, public company documentation.
Maximum openness. Okay, what's next?
Then we have internal. And this one is often misunderstood. Internal means the content is accessible only to users who are logged into your specific GitLab instance.
So they have to be an authenticated user within my organization's setup.
Right. Even if they aren't an explicit member of that specific group, if they can log into your company's GitLab, they can see that the project exists.
So I can see the list of internal projects, but I can't necessarily touch the code or the issues unless I'm actually added as a member.
Exactly. And the key security feature there is that it prevents public enumeration of your company's internal project names. It's a huge step for corporate security.
And finally, the highest level of restriction.
Private. Private groups and projects are only viewable by explicit members, people who have been specifically invited and added to that group or project.
So if you're not on the list, you don't even know it's there.
You don't know it exists. This is for all your sensitive data, client work, internal compliance stuff.
Okay, so let's run a scenario here. What happens if I set the parent group to private, but then I accidentally set a subgroup, say 3 levels down, to public?
Great question.
Does the narrower public setting override the private parent?
No. And that speaks to the rule of precedence. When it comes to restriction, the settings are always restrictive going down.
Ah, so a parent group's visibility acts as a ceiling.
A hard ceiling. If the parent group is private, nothing nested beneath it, no subgroup, no project can ever become more visible than private.
So the top-level group establishes the maximum allowed exposure. You can't escape it.
Precisely. You can always restrict access further down the chain, like making a project private when its group is internal, but you can never, ever loosen the restrictions set by the parents.
That makes perfect sense for visibility. But now we have to move to the concept that manages actual user interaction.
Yeah.
The ability to commit code, manage issues.
This is where things get serious.
And this is where many large organizations stumble. It's how permissions flow. It's known as inheritance.
This is the single most crucial concept for anyone managing security in GitLab. If you miss this, you will have permission gaps, or, worse, critical security vulnerabilities.
So walk us through the mechanism. Why is it so rigid?
So, inheritance is the mechanism where permissions flow down the hierarchy. Let's say we define a user's role, maybe developer access, in a high-level parent group.
Okay.
That user's membership and their access level are automatically inherited by every single subgroup and every project contained within that structure.
So the higher up the chain you grant someone access, the wider their reach automatically becomes.
And here is the absolutely crucial rule. Membership is sticky.
Sticky.
Meaning you cannot lose permissions as you move down the chain. If a user is a maintainer at the parent group level, they automatically retain at least maintainer access across all nested subgroups and projects.
Okay, let's play this out with a real-world scenario. I'm a global maintainer, granted that role in the top-level corporate group.
Right. You have the keys to the kingdom.
And now I move into a specific project on the infrastructure team, which is, nested 5 layers down. The local team admin, trying to clean up their list, decides to demote me to guest access on that specific project. What happens?
The local configuration attempt fails. It won't work.
It just fails.
You remain a maintainer in that project because the parent group's inheritance rule trumps the local setting. The system guarantees that access granted high up is preserved everywhere below it.
That's fascinating. It sounds like a very deliberate organizational design choice, prioritizing centralized control over any kind of localized autonomy.
It absolutely is. And this rigidity is what simplifies massive organizational management, instead of manually adding 10,000 employees to 200 different projects.
With 50 different subgroup configurations.
Yeah, forget that. You add them once to the top group, you set their role, and the system handles the provisioning instantly and immutably.
But the flip side of that simplicity is a massive security burden on those top-level admins. A single mistake giving the wrong person maintainer access in the parent group cascades immediately.
Immediately, across every single project in the entire company.
Wow.
The parent group level demands the highest possible scrutiny, audit logs, careful management, because its configuration affects the security footprint of literally every asset nested beneath it. If you have a security audit, that's the first place they'll look.
The membership list of the highest level parent groups, those are the master keys.
They are the master keys.
Okay, we've covered the entire journey. Let's do a rapid recap of the core concepts for you, the listener, just to cement this structure in your mind.
First, you start with the namespace. Is it a user namespace for your personal work or the much more critical group namespace for collaboration?
Then you build the hierarchy, you use groups to organize, and you leverage deep subgroups to reflect your company's complexity and regulatory boundaries. And inside those are the projects with the actual code.
Then you control who can see what using visibility levels, public, internal, or private. And you have to remember that parent groups always establish the ceiling for that restriction.
And finally, you manage user access through that powerful, immutable rule of inheritance. Permissions throw down, and once they're granted by a parent group, those rights cannot be revoked locally.
And understanding this isn't just theory, it's the absolute backbone of efficient operations and, frankly, of preventing security vulnerabilities.
Right. Mastery of these concepts is what differentiates someone who just uses GitLab from someone who actually administers and secures an entire organization on the platform.
Exactly.
So we've established permissions flow down and can't be revoked locally if they're granted high up. But let's end with that deeper thought experiment for you to chew on based on all this complexity.
Okay.
If your company uses this deep, nested group and subgroup structure to accurately mirror its real-world team map, and let's say a critical senior engineer is leaving the company, or maybe they're just switching from the development team to the marketing team.
A common scenario.
Given the stickiness of that inheritance model and the potential for residual access through dozens of parent groups, just consider the organizational complexity. The sheer number of places an administrator would need to check to manually revoke that powerful user's access, just to ensure they have no lingering permissions on sensitive code bases.
The complexity of a global revocation, even for a simple role change, it highlights why this structure demands such strict governance right at the highest levels.
That's definitely something to mull over the next time you structure a group. We'll catch you in the next deep dive.